Hey guys, this is Neutron Star 714. Today we're going to have a close look with the halogen element iodine. Here it is, some elemental iodine. I'm only gonna take out a small amount. As you can see, in its pure form it has a dark gray color. Like its deadly cousins, it's quite reactive. It's a solid at room temperature, but it has low melting and boiling point, and sublimates at room temperature. To prove it, I put them into a beaker and cover the top. Over time, the vapor gathers and gave the beaker a magenta background. If you give it some heating, the vapors are even more violent. The iodine grains are fuming. Make sure to put a beaker full of cold water on top so that vapor can condense and form small crystals. Wear a respirator when doing this experiment, because the vapor is quite toxic. Because it sublimates at low temperature, there's a myth about iodine that say it doesn't have its liquid form. In room temperature and pressure, it goes straight from solid to gas. But look what just happened in the beaker. It's liquid iodine. If you look at this graph, the triple point of iodine is lower than 1 atm of air pressure. Unlike carbon dioxide, you have to increase the pressure to 5.1 atm to make liquid carbon dioxide. I turned off the hot plate, then let it cool to room temperature. You can see a layer of iodine crystal on this glass dish that I used to cover the top of the beaker. Luckily, iodine dissolves in ethanol, and the ethanol solution is way more safer than elemental iodine. The color of the solution is very dark. I think it's just a really stupid way to turn iodine to bromine. The next part of the video, I'm going to show you an extremely exothermic oxidation reaction between iodine and aluminum. To do this experiment, we need both of them to be powder, so I put some small pieces of aluminum foil to a coffee grinder. It would take a long time and the grinder always overheat after a minute of non-stop grinding. It was a few days later and I finally transformed all the foils into powder. For the iodine powder, I squished the grains to smaller particles using a spoon. Then I put it in the triple beaker. The crucible is ready and it's time to get the two powders in and mixed. When I'm mixing the powders, you can see some vapors coming off. Actually, the reaction started, but it's really slow. To fix it, just add some water. The water will dissolve a little bit of iodine and mix the two reactants to increase the rate of the reaction. As you can see, immediately lots of purple vapor are coming off. Inside the crucible, a red flame appeared. Aluminum reacts with all the halogens, but its reaction with bromine and chlorine are much more violent. When the reaction is done, I left the crucible for a few days. I use ethanol to clean the beaker that contains the iodine powder. To deal with the waste in the crucible, I threw the leftover aluminum powder to sodium hydroxide solution to destroy it. It creates a lot of hydrogen gas bubbles. Well, I think it's pretty funny. At the end of the video, I managed to make an ampule full of iodine. Heating it will cause the iodine to vaporize and create a purplish background. If you want to know how do I make these ampules, make sure to check out my channel. Anyway, thanks for watching.